Today, we are going to be doing similar to what we did yesterday, except I think you're going to find it just a little bit easier, actually quite a bit easier. But in addition to finding it, I think, a little bit easier, it's going to be one of those things that we're being kind of repetitious. Yesterday, we had an angle measurement that was less than 360, so you were able to automatically graph it, excuse me, on your XY axis, and just then find your reference angle, then using your special rights, able to find the measurements of each one of those sides. Today, we're going to have to do just one extra step. If you look at these, well, like if you just look at number 1 and 2, what do you notice about those angle measurements on those? They're over 360. So guess what my first step is going to be? I'm going to have to subtract 360, and then once I find an angle measurement that will actually fit onto the coordinate plane, then we'll be able to graph it, then find our reference angle, then be able to get our measurements in, and then be able to find the exact value of that particular trig function. So the first step is we're going to take 495, and just like you said, I'm going to subtract 360 so that I can get it to where I can graph it. And I think that ends up to be 135 degrees. Now here's a question from one of the very first lessons that we had in this section. What kind of angles would 495 and 135 be called? What's that word? When they end up and they have the same ending position. Close. Co-terminal. Co-terminal, okay? So 495 and 135 are both coterminal, which means they end up in the exact same position. So what I'm going to do is I'm going to graph 135 degrees. That is in the second quadrant. And if I would start at the initial, with the initial ray right here on the x-axis, if I went from here to here, I would have gone 135. But the original angle is 495. Okay, so just understand, you don't have to show that, but understand that that's the same place, and that's the same thing as 135. Do you guys see that difference? Okay, those are called coterminal. You do not need to show that 495 and all that. Okay, what I'm looking for is right here. I'm looking for theta. And this is what we did yesterday. And so as I drop down my perpendicular line to the x-axis, this is 180 degrees out here on the left-hand side. And so how do I find this angle? What do I subtract from what? Perfect. 180 minus 135 leaves me with a 45-degree angle. Now, you guys, for those of you that did complete your homework, which I'm assuming everybody in here had their homework completed, on this 45-degree angle, on a unit circle, because remember, even though it's not drawn, we can assume this to be a unit circle. What's my hypotenuse? 1. And to go from my hypotenuse to my side, I divide by the square root of 2. And so you're going to be seeing, again, that's going to be very repetitious, the values that we're going to have for these lengths. Anytime that I have a 45-degree angle, I'm going to have 1 over square root of 2. Always. Mrs. Meyer, forever, forever. As long as that hypotenuse is 1, we're on a unit circle, a 45-degree has 1 over square root of 2 sides. But the only thing that's a little bit different, if I'm going to the left down here, what kind of 1 over square root of 2 do I have? It's negative. It's negative. So I want the cosine, which is adjacent, and it's always this interior angle, or excuse me, this central angle right here, over the hypotenuse. Adjacent over hypotenuse, so I get negative 1 over square root of 2. That's my final answer. Kind of sloppy up there, I apologize. Okay? So the only thing different from today versus yesterday is this step here to get it to where I am less than 360. Okay? Now I'm going to just go ahead and jump down to number 3. And just for those of you that love to work ahead, I'm going to do 3 and 4. We'll skip number 2 because we just subtract from 360, subtract from 360. So let's go ahead and let's look at number 3. What's the first step that I need to do with number 3? It's in radians, so I need to get it to, degrees. So I multiply by 180 over pi. So on your calculator, you can take 19 times 180, divide that all by 4, and you're going to get 855. That's almost as old as I am. I know, I look pretty good for that being that old, don't I? All right, minus 360. I'm probably set a world record. And you end up with 495. Say, what? I'm still not less than 360. So we've got to do it again. And I'm right back to the same drawing that I would have above because I'm looking at a 135-degree angle. No big deal. We draw our angle out. And if I was to draw 855, I would do 2 rotations and then some. Because there's 1 rotation, there's a second rotation, and then the 135 is the and then some. But I do know that this is the 135 here. So I have several coterminal angles here. 855, 495, and 135 are all coterminal. And this still creates a 45-degree angle here. Negative 1 over square root of 42, negative 1 over square root of, I have no idea what I just said. Negative 1 over square root of 2. On the adjacent side and the opposite side is 1 over square root of 2. I want tangent. Tangent is opposite over adjacent, which is sine over cosine. And anything divided by itself is what? 1. But I have one of them that's a negative. So therefore, my answer is negative 1. Because basically what I'm looking at is I'm looking at 1 over square root of 2 divided by negative 1 over square root of 2. Those are the same except for the negative. I'll bring the negative up, so it's just negative 1. Okay? Cosine. Yes?
Can we draw out the 855 degrees, or would you prefer us to do just the small one?
Indifferent. Indifferent. Whatever helps you understand it the best. But understand that when you get negative 1, what you have found is the tangent of 855. Okay? So now I want the cosine of 7 pi over 3. Again, I want to get it to degrees. Pi's cancel. So I'm going to take 7 times 180 divided by 3. And I think that comes out to be 420. That's bigger than 360. Guys, if I'm going too fast, let me know. If that's bigger than 360, then we need to subtract from 360. And the purpose of that is so that we can graph it. And I end up with 60 degrees. 60 degrees is a nice angle because it's located there in the first quadrant. And with the 60 degrees, I know that's my 30, 60, 90 degree triangle. And on a 30, 60, 90, I always want to get to the short side. So the short side is along the x-axis down here because that's opposite 30. To get to the short side from the hypotenuse, I divide by 2, so it just becomes 1 over 2. And then to get to the medium side, I multiply by the square root of 3, so I get square root of 3 over 2. That's in the first quadrant, so everything should be positive. I need the cosine of 420, so cosine is adjacent over hypotenuse, so 1/2 over 1, which is 1/2. Okay? So really, the only thing different from yesterday and today is just whittling it down to get it less than 360 so that we can put it on a graph and graph it to find that reference angle. Okay? All right. Now, we're going to talk about something that we've seen, but yet we haven't really spent much time discussing. So down here, I've got my x and y axis. Over here to the right-hand side, when I first start to graph, this is my initial side. If I don't rotate my ray up or down, how many degrees have I gone? If I just stayed put, I'm at 0 degrees right here. If I go up if I go up 90 degrees, I just gave you the answer. How many degrees am I here due north? 90. I come over here to the right-hand or left-hand side. What do I have? 180. Straight down below, 270. And if I make a full circle, I have gone 360 degrees. Okay, so we all know those angle measurements. These angle measurements do not lie in a quadrant, because typically it will say, are you, label your quadrants. Are you in quadrant 1? Are you in quadrant 3? Are you in quadrant 4? Well, what if the angle is 90? There's no quadrant, because 90 degrees, 180, 270, 360 are called quadrantal angles. Quadrantal, okay? Kind of like almost sounds like a slang, got me some quadrantal angles over there, got me some, that's an angle that is not, they don't lie in any quadrant, okay? They do not lie in any quadrant. And again, if I would make this into a unit circle, hey, that's not too bad. If I would make this into a unit circle, again, I know that if I had a spoke on a bicycle, all those spokes, the distance of the spokes would be a unit of 1. So if I wanted to put a point at 0 degrees, a point at 90 degrees, a point at 180, and a point at 270, I'm going to write it as xy, but remember, that is also cosine, comma, sine. Okay? That's not new. So at 0 degrees, what would be my coordinate point at 0 degrees? I go over how much? I go over 1 unit, but I don't go up and down, so it's 1, 0 at 0 degrees. If I rotate up to 90 degrees, starting at the origin, if I was to graph that, I don't go right or left any, so I'm at 0, but I go up 1. So at 90 degrees, I'm at 0, 1. All of this we included on our unit circle. It's all there. At 180 degrees, starting at the origin, if I was to graph that, I'd go to the left, -1, but I don't go up or down, so that's -1, 0. And then at 270, I don't go right or left, but I do go down 1, so I'm at 0, -1. And then I come back to 360 at 1, 0. Okay, everybody see where those points came from on that? So now what we're going to do is we're going to fill in this chart here to the left. What is the sine value of theta at 0 degrees? Well, I go to 0 degrees. I see my coordinate point of 1, 0. I understand that sine is my y value always. So what's the y value at 0 degrees? 0. Now let's go to 90. What's the y value at 90 degrees? 1. What's the y value at 180? 0. Y value at 270? I'm not sure, guys, why I stuck that up so high. -1. And at 360, I've made a full circle. I'm back at 0. It's a nice little pattern. 0, 1, 0, -1, 0. These points are going to be extremely important in our next unit. We're going to be graphing this. You'll see that coming up. Okay, so 0, 1, 0, -1, 0. Now let's do the same thing for cosine, but instead of looking for the y value, we're going to be looking for the x, because cosine is the same, located in the same position as the x value. So cosine of 0 degrees is 1. Cosine of 90 is 0. Cosine of 180, -1. Cosine of 270, 0. And back to 360, I'm at 1. So same kind of pattern, but just in different positions. 1, 0, -1, 0, 1. Now tangent theta is y over x, which is the same thing as saying sine of theta divided by cosine of theta. Sine of theta, cosine, we can do this in our head. So at 0 degrees, sine 0, cosine 1. What's 0 divided by 1? 0. 90 degrees, sine 1 divided by cosine 0. If I divide anything by 0, what do I get?
0.
If I divide anything by 0, what do I get?
1.
Do it on your calculator. Take 1 divided by 0 and tell me what you get.
Error.
I get error because it's undefined. There is no solution. We can never divide by 0.
So we leave it.
So you make it undefined. Don't leave it blank. So I go to 180. 0 divided by -1, 0. 270, I'm back to that same situation. -1 divided by 0, undefined, no solution. And I end at 0 divided by 1 at 360, which is 0. And again, all of those are located on your unit circle. And we will play with those probably starting Friday, and how they can be literally graphed on a graph. Okay? All right, so questions, we can see that this is very similar to what we did yesterday, as graphing it, finding an angle that will fit on a 360, finding the reference angle, and then using our special rights to find the exact values for the lengths of the sides, and then writing our ratio that way. Okay?